to start this recording just to have it going. I'm a little behind on the other uploads to YouTube, but those other streams or edits of them and stuff should make their way to my YouTube, the public YouTube channel. Yeah, Patreon was doing some funny business with the getting into all that stuff. It's too bad. I remember even a while back, there was like some sanctioning happening of Venezuela, and Adobe turned off all of the Photoshop like cloud licenses for everyone in Venezuela. It's like pretty sad that these big companies are so intertwined into what we're doing that it's frustrating. But Linux, that's one of the reasons I like to use Linux. You have more just community developed and controlled, so you don't have to worry about that kind of funny business. Francis Tejuar. Thank you for the tier 1. Ali Miao. Ligao. So yeah, I'm in 19.5 here, and I'm just gonna keep going a little bit with some of the particle techniques we did a week ago on the last stream. And this was all with Redshift, but I was gonna start looking at Karma and the different options we have with Karma, CPU and XPU based. And just to get started, I'm just gonna make a little test scenario or just set up some particles. My 19.5 settings are still kind of getting like, I'm still integrating them all the way or whatever, so I might be changing some UI stuff along the way. But for right now, we can get started with this sphere, and I'm just going to put down a scatter node. I was planning to do some stuff here with a for each loop. With Linux Mint, are you using Cinnamon or Mate? I'm using Mate, I'm pretty sure. 90% sure. I think it's like Mate Tina is the official one or whatever, but I'm not a huge, super knowledgeable person about like the in-depth inner workings of Linux. But yeah, I don't know if I'm at a point where I'm like upgrading and moving computers or migrating things, I might put on a few different builds, install Houdini, and just test drive it and see how it's going. But overall, I mean, I just stick with what works, and there's not other UI or like features of Linux that I really need to use. So just whatever's like stable and more efficient or optimized for memory use and stuff like that is usually what I end up sticking with. So we could try this for loop thing set up in feedback mode like this. I'm gonna try to make like a little simulation or non-simulation based like particle test effect or geometry. So this feedback stuff, I'm just going to leave it empty at first, but this node right here is just going to keep grabbing whatever is at the end of this loop here. Gave the opportunity to pop OS, but didn't like it, so I went back to Mint. Yeah, there were some other Linux initiatives. I think we were having a discussion about it in the general chat or something. There were some other Linux projects and stuff like that that were discussed. There's definitely some things kind of on the horizon. I think the Arch Linux team is making a new branch or something like that that's this Crystal Linux. So I think this is I was reading a little bit about it, but they're trying to basically, it's not for the beginner, but it's a little bit closer to the beginner from where Arch Linux is like just for serious people, but this is meant to be, I don't know, somewhere in between maybe, and still optimized and efficient. The Clear Linux stuff is somewhat interesting. This is like made from Intel, and it's supposed to be really good for kind of simulations and like heavy data intensive tasks and stuff like that. Very optimized, but I think I tried it a while ago and had some issues with some applications and stuff like that, so I never really got into it. But yeah, other than that, if you just go to the VFX reference platform website, they have a whole section on Linux and videos you can watch. I think they have a whole guide, some PDFs and stuff like that. Distribution recommendation report. This could be helpful if you're looking to get into Linux or more information about this kind of stuff. But overall, I've just been sticking with the Linux Mint. To me, I think of it as similar to Ubuntu, but the UI or the desktop is like more of a classic Windows 95, Windows 97 era or something like that. So it's just super minimal or whatever. I don't need a ton of funny animations and things fading in and out. Like generally, if you're doing Houdini stuff where the GPU could be taxed quite heavily, you don't want to be like doing all these fancy desktop animations on top of it. How valuable is it to study maths for CG? I think with Houdini, it's the most necessary out of all the 3D softwares. Like if you're looking to do effects, especially, and not just like lighting or some of that stuff, it's pretty important to know like basic vector math and that stuff. If you just search for like math for games, generally these talks and stuff like that are the most relevant to Houdini. A lot of it's just vector math, like math in 3D space, and this is like super basic. But yeah, it's helpful to know about that kind of stuff with this, and even with rendering, you talk about vectors and reflections and collisions and stuff like that all the time. All right, someone with not launching, someone said that there might be like a glib compile error or something. In general, I would, if I'm using MintOS or downloading Linux stuff, like for stability purposes, I would try a few trailing releases, like not the bleeding edge or the newest release of the operating system. Someone mentioned on the side effects, maybe it's somewhere here in the compatibility system requirements. There's this maybe glib issues or some stuff like that, but on the side effects website here, they'll say this is like the official LTS or long-term support things. So maybe it looks like with Mint they're recommending 19.3 plus. So if possible, I would say it's good to grab an older thing. So I'm actually on 20.3, but if you can stick with 19.3, it's probably going to be more stable or whatever. Yeah, the latest one generally for visual effects or computer graphics work, like people will try to stay somewhat far behind. I mean, there's not maybe graphics drivers you need to get pretty new if you're doing GPU rendering and stuff like that, but other than that, just there's not really many gains or like active optimizations in terms of getting more bang for your buck with the Linux stuff. So if you have something that's working, I think it's best just to stick with it. So I'm going to grab this input here, and I'm going to think of this kind of like an emitter. Yeah, we're going to be looking at particles inside of Houdini. Last week we were looking at particles with redshift, and then today I still have some of these caches on disk, I think, so we could pop them open, but just so we have some other topics and things going on, I'm just going to build a quick little particle test situation. So we have this, I'm kind of thinking of it as like an emitter, just some starting particles, and then this is like the feedback. So if we do a merge here, like that, instead of all of these just being single particles, if we go to the end, you can see we're doing the feedback. So here, this is actually 10 copies of all the particles, just keep stacking up on each other. If we take let's just do this attribute noise vector, and maybe we want to add it here. We can have this affect the point position, and I think the rest of the stuff is good where it is. Maybe just the amplitude. You can see kind of what we're doing here is it's maybe similar to like a trail SOP, or it's similar almost to a SOP solver where every iteration we're just moving everything a little bit and then getting new source or new fresh geometry from down there. And then if we want to add some variation to this so it's not all connected like that, we can add the meta import node, and then this way we can get some detail attributes or information we can use. If we do the spare input, we can grab that, and then the global seed, we can basically tell it to update or to get a new seed every iteration. Just like that. And now we're just updating the distribution of the particles every time this runs. So that's pretty cool as a first step. Maybe with this one here, we can change the element size. Maybe we want it to be smaller, a little bit kind of higher frequency or something like that. And then we could play around maybe with our starting particle count. Maybe if I press the D key, we'll just go into the pixels mode just to be able to see a little bit more detail or information about what's going on. And should be okay for now. How often do you upload these streams to YouTube? I generally try to upload them all. Sometimes if I encounter too many errors or make too many mistakes, I'll try to cut out some parts, or it will get omitted, but in general I try to upload them. Twitch will keep these VODs, the video on demand, online for 45 days or something like that, I think. And sometimes I'm a little behind getting the videos up, uploading them to YouTube and putting the scene files with them and everything like that. But generally my goal is to get all of the VODs or all those streams on my YouTube channel. You would do the YouTube command. So that's where it is. And that's where they'll go for kind of longer term storage. If you need to access older VODs, you can find all that stuff there. Super Simpa, how's it going? So we're just doing 12 kind of loops or repetitions. We could try doing more, and we would expect to see this stuff kind of blowing away or shooting out a little bit more. I was just looking to get some basic interesting kind of motion or behavior happening. And then we can pull these in and start using them with karma. So I'm going to go a little larger scale on the noise. Maybe something like that is a little more interesting to have those sheets. We could adjust the noise detail, maybe add some extra octaves or layers of noise. I don't usually mess with like the lacunarity that much. I don't know. It could be interesting to try in this case, but I have a feeling they have it dialed in at a pretty good amount. So sometimes if you mess with it too much on your own, you can generate like bad outcomes or whatever. But I don't know, this could be interesting. And then sometimes with this offset, just getting it away from 0, or what I'm going to call the origin, is helpful. So if you do all your noises like at 0 or at the origin, sometimes it just doesn't it will always be kind of lopsided or something like that. It will never be as random as you would want. So something like that should be a good starting point. And Heck1, thank you for the Prime. I'm just going to increase this overall density or emission. You kind of think of this as an emission rate up a little bit, just to give us some more overall like total particles. Alkama, good to see you in here. How is the demo scene world going? So these updated, if you see some of these like back to physical events, that's good to hear. There was something in the Netherlands recently, right? Paul, good to see you in here. Thanks for stopping by. Yeah, I'm interested in going to some of these demo events, but that one was going to be too far away. So I'm just going to reduce the amplitude here, and we're just going to be pushing this stuff a little less each for loop iteration. And we should kind of resolve that artifact. It's similar pattern or similar shape to like a substepping issue, or basically you just push particles and stuff like that too far during a loop, you might get that kind of error. So I'm going to decrease this count and then maybe increase the iterations to kind of balance things out. And then we can pop this into Solaris, see what's going on. I might be able to do a trip to Munich sometime. But yeah, I haven't made it too far outside of Portugal since I've moved here yet. Just because I was working on the visa stuff for a little bit, but I think I'm fully qualified to to roam around the EU now without worrying about getting stuck in another border or country or something like that. But yeah, the next European like Houdini meetup or hug, EU hug or whatever it's called, I'll be interested in checking that out. They're doing like FMX. That was in it was in Germany, right? Portugal, yes, I am working remote from Portugal, and I'm not planning to use pop simulation for this right now. I was just kind of having some fun and building something more procedural that looks like a simulation, but perhaps after we set up some Solaris stuff, we could put in a pop solver and see what's going on. But I just wanted to get into the basics here with something that's not simulation based. We don't have to worry about simulation caches as we're just like testing stuff or whatever. So I'm just going to use the SOP import now to get our points we just made. And you could also do all of this inside a SOP create and jump down into like the creation level or SOP context within Solaris. But for me, if I'm still testing things, I like to have the ability to go back here into the object level and still do a traditional redshift render. It's just more easy to switch back and forth as you're transitioning. And then in terms of performance, I think some people have done tests and it doesn't seem to be any speed benefit or anything like that working in the SOP create. That's just a kind of HDA or tool that's just kind of wrapping all of this stuff up to one easy container, but it doesn't give you any speed boost or anything like that in terms of working more efficiently. Now we're in Solaris and we're looking at these particles. We could try Karma, and you probably see something like this at first. So by default, Karma I think will render unconnected points as spheres like this or particles, and you can control this size or the radius using the p-scale attribute. So that's pretty cool. I might change one thing. I'm just going to go back into here, and instead of putting these on the surface of the sphere, we'll just convert it into a fog or do a cloud. So this would just fill everything up with density, and then we should be basically sourcing from the volume or the inside of the object instead of just the shell. And I think for this, testing this or whatever, it just will look a little better having some insides going on with this stuff. I'm just going to escape out of that. I think if you're scattering on a volume, you want to disable that relax iterations because it would like slow it down. Or all right. So now we're back here, and basically this is just looking maybe a little bit more uniform in distribution. They're not all stacked up on the surface or the shell or whatever. If you want, you can go into well, maybe we'll do that later. So we'll just continue building things out here. You can add an actual light. Then with Solaris, basically you need to be keeping this display flag as like it will collect everything. So even if it's connected to the chain, to actually visualize it, it's somewhat similar to SOPs in that regard, that you need to put it on top like that. So we just have a basic light, and I'm somewhat still on. I somewhat just started, but yeah, I'll just switch this background to dark. And usually working with renderers and stuff like that, this is maybe a little bit nicer to have the black background. With the texture here, I did find one thing somewhat recently. If you go to the $HFS, the HDRIs that Houdini comes with are a little not my favorite, but if you go into the MaterialX folder that they ship with the Houdini install, you can go to resources and then lights, and then there's some HDRIs here that give you some nice kind of harsher shadows, a little bit more crisp, that might be nice to try out. These, I think just the way that they're captured, or like the tone mapping or something like that is happening, is a little bit better than some of the default HDRIs that Houdini puts in the other like pick directory or whatever. So generally you can get some nice kind of two light, kind of sunlight and bounce light, or just like a very, very good outdoor lighting using those MaterialX HDRIs. And then if we want to do materials, it doesn't particularly matter what order you're putting all this stuff in. For certain things it might, if you have wildcards and things that would be getting everything, but the way that Solaris works, we can take a look at it, is that we're basically building this scene graph tree that's like a render description. So we have lights and we have the SOP geometry, and like even if I flipped the order of these around, we would probably end up with the exact same scene tree. So in certain cases it doesn't really matter what order you connect them in, but for sure if you're doing like this light is going to affect everything above it, then you might, if you're working layers or some things like that, it gets a little bit more advanced. But just doing simple things like this for right now, you don't have to worry too much if you're just doing lights, camera, material, SOP geometry. The material I usually put below the geometry because we're going to assign it to the geometry. And then should be good. In here, if we just double click, we can do, might want to do the Karma MaterialX subnet, and we could maybe just get rid of this for right now. And I'm just going to do the standard surface for MaterialX. And the displacement, we can get rid of that. And then just testing stuff, I'll usually make kind of a saturated or something color just as like a test to see if it's actually working. And then we should just have to do assign to geometry. You can do the drop down here if you want like all geometry primitives. If you have other geometry that you have like being used, instead of doing that drop down to do all geometry or stuff that's boundable, you could grab this import prefix here, just Control-C, Control-V, and that's like this actual name that it's showing up as down there. So you should be able to paste that in as well. So this way, if you had like a ground plane or some kind of extra geometry, you're able to just catch specific portions instead of, these are just generally tend to be very broad, like nets or just ranges of geometry and stuff like that that they would be catching. So you can move the ground plane down a little bit here. Oh, I moved it. It's going up, down, up, down. All right, so now we have some shadowing, and yeah, I think with these MaterialX HDRIs, like generally you don't get such nice crisp direct shadows with HDRI, so I've kind of been liking these MaterialX ones for right now. The other nice thing about Karma, or just the Solaris layout, is that I find it easier to switch out different lighting setups and compare them more quickly. So if we did want to go into the just standard HDRI directory, maybe compare a similar outdoor one, you can plug them in and out like that. So it makes it a little bit more convenient for kind of A/Bing or trying on and off different light setups or cameras or all of that stuff. You can see this one is quite diffuse. We don't have too many hard shadows or direct shadows, but of course you could even kind of mix and match stuff and use this one as just an extra kind of fill light. You have many options that make it a little bit easier to try out things and just test stuff in Solaris like this. So we have the particles. We're not rendering too many of them right now, but we could definitely test some more. Another thing that I haven't started, or before we do this, let's go into the material, and I'm just going to increase the specular roughness. So I feel like in general with particles, you don't want the specular highlight to be too crisp, depending on how big they are. But if you want like a more general, smoother highlight to everything, making a like broader specular response will give you a more like cohesive shape overall. There will be less kind of little bright spots or noise or whatever, like illuminating parts of the particles. So generally with particles, I'll go to a bigger one. If you go to Karma Perspective, you can go into this image viewport right there, and then this will give you more of a traditional, you might need to make a camera for that to work. So I can just control click on the camera shelf, and that will attach one. The image viewport can be useful if you're more comfortable working with like a traditional render thing that you can actually zoom in and see, like enlarge the pixels and see what's going on. So usually with the Karma viewport or the Houdini like Solaris viewport, you're adjusting the render every update you do, but this image viewport is a little bit gives you just more traditional kind of flexibility with some of that stuff. So you can pan around and crop in and everything like that. Shades of Orange, thank you for the 27 months. Good to see you in here again. So there might be some other hotkeys as well for doing some image sampling or getting some more image information, but I'm not 100% sure on all the secret hotkeys for Solaris stuff yet. So yeah, I mean, just getting a sense that stuff is pretty cool. If you want to switch to XPU, you can press the D key, and then if you go here to render, you can switch from CPU to XPU. And XPU is still supposed to support this standard surface here of MaterialX, but it might not do the custom PBR, like lobes or whatever. I don't know which of these you'd be using, but basically it doesn't support any of these individual PBR kind of BRDFs or whatever. I don't know, maybe like the subsurface one or something like that. You would need to do the MaterialX surface. Like, basically you can't get as granular with your material creation. So if I try this here, it looks like it's not really going to work. But if I pop back into CPU, you're getting some more subsurface, you're getting some extra interaction and stuff like that built in. I think my radius for the subsurface lobe is like a little bit too ridiculous right now, and that's why it's looking a little bit weird. But you can do more advanced things if you stick to the CPU render. Basically, the XPU stuff is in beta. There's more details on what's supported and what isn't supported in the documentation. But overall, just know that you're basically just getting the best speed that you can as a trade-off of less customization or less ability to do that kind of stuff if you're doing the XPU. Stable has XPU been in your testing? In general, I would say that the Solaris stuff is still pretty unstable for me. I think there's just a lot of areas in it inside of Houdini, that bugs that you can run into and still. But yeah, in general, I think with the whole managing the USD file and like updating it, that type of stuff seems to be a little bit buggier to me than just other areas of Houdini, I would say. So that's pretty cool. One thing we might want to try that's somewhat standard would be like traditional texture attributes or things like that. So if we look at this emission geometry, we could start here with this color node, and I'm just going to set it to bounding box. And then this way, as the particles are created, they'll have this bounding box where it's kind of just the rest position that we could use for like different gradients or different stuff like that to play around with. That's pretty nice. I might play around with my noise settings a little bit more. Just try to get, I don't know, maybe like a little bit more detail or stuff happening there. So it's not too bad. Half hour or so in, and we're at least getting some renders and stuff going. I feel like in some of the streams, it's like 2 hours in, I haven't even started rendering anything yet. So we have these updated particle shape, and they aren't getting the color, but that's just because the shader I'm using right now doesn't have any hooks or ability to grab that information. So we can jump in there now and should be able to, I believe it's under this geometric color property value. I think it's one of those two. The color one might be just a little bit more convenient because it's already good to go for you. I think if you're doing this, trying to read the property value directly, I think it's like display color is a USD syntax for reading the color attribute. In Houdini, they call it CD. So either one you can use. I think this color one's maybe a little bit more straightforward because it's harder to mess up. And then could maybe do try to do some more advanced stuff. If we separate this, we could get the individual channels, so you could pull just like a gradient and get something that's a little bit more minimal or something like that. You can do power functions if we want to remap some aspects of this. Fall off for the gradient, and maybe the last thing we want to try is a ramp. Color ramp. So this will just let us remap a black and white value. You have some presets and stuff like that that you should be able to pull from if you want to auto-populate this and just get a little bit more of an interesting stuff happening with the particles. We're still with XPU, so it's nice. All of these custom attributes and stuff like that are somewhat supported. And then another thing that's cool is you can pin the viewer here in the Solaris viewer, but you could go back into the SOP geometry, and you can still kind of work in the SOP context, but be viewing your live render. And it's pretty quick to update. So if I just try changing the default P scale, I think 0.01 is the actual default value that it was pulling. But if I try something lower, sometimes you need to do maybe this restart. And I made a classic mistake of not calling this P scale. So now it will work. And I believe 0.05 is actually the starting default. So we're able to see this come up pretty quickly now. And then maybe another thing, we want to increase just the overall count. Generally, if you're reducing P scale or radius to make up for that, you might want to create more particles. So it's going through and doing those iterations now. And then filling them in. So we're up almost 5 million total particles now, and it's still pretty responsive, which is nice. Another thing you might want to think about doing if you're used to working with traditional renderers. So I was showing earlier, we could go into the, let's just update our camera. So earlier I was showing you could go into the image view. That's just a traditional 2D image plane that we're rendering to. But you just need to supply it with a camera to be able to do that. So let's get up here near the top where the interesting stuff is happening. And then if we go into the image viewport, I think I jumped on the wrong one there. Get in the camera and then go into the image viewport. This is still punched in a little close. So if you press the D key, you can as well switch from progressive to bucket render. And it'll generally do a first kind of pass to resolve noise, but then it should start kicking up the buckets. Just depends on how you're used to lighting and rendering, but some people prefer to work with these buckets churning away, where you could see fully resolved areas of the image instead of like everything gradually resolving or anything like that. Skadooks! Billy, good to see you. Thank you for the 5 months. Tossing these gems out here. So yeah, that's just another thing depending on your lighting preference and how you prefer to work, but just depends. So I'm going to go back to progressive. Maybe you want to increase the diffuse limit. Theoretically, if we're doing GPU-based rendering, we should be able to do quite a few bounces and not really have to wait that much longer in the actual render time. You can as well do if you're on Linux, you can do this NVIDIA SMI command, and it should give you a current printout of how your GPUs are being utilized. But with the XPU, it's meant to try to juggle CPU and GPU. So you can see here my CPUs are being fully utilized, but the GPUs not so much. So I don't know if that's part of this Embry CPU. That's like an Intel thing that all the XPU stuff is basically an Intel implementation, or kind of like an alternative to some of the CUDA GPU programming, or like maybe even supposed to be better than OpenCL or whatever, but that's just what is going on there. So I'm going to go back into the perspective view, and another thing we can do with these particles, actually before we do that, let's just pause this thing here. Time to first pixel seems pretty quick. Yeah, I think as long as you're not throwing too much geometry, like 20 million, 50 million particles, that seems generally slower, but overall I'd say it's pretty responsive, especially for being all USD compliant and everything like that. Put this in a new directory here. We're in September already. And do scenes. And we'll just call this Karma Particle Basics 01. And then if you want to grab it, you should see a link pop up to this scene file in the chat in a second. And I'm going to keep moving ahead here now for AMD CPUs. It should, to my knowledge, I'm not 100% sure, but I think it's meant to be an open standard, and I think with like even the ARM, like the Apple Silicon or the other architectures that's not Intel, pretty sure it works with that as well. So go back into stage here, and you can't directly render these particles as volumes, but one of the things you can do that might not be the best idea, but it's possible if you go to geometry, you could decrease the opacity. So this way you can get kind of a volumetric type of effect. You can see it's getting a lot slower. It's basically a lot of, as this stuff becomes transparent, it's just a lot of extra work that the reflections, shadows, and just the renderer has to do a lot more work to finalize that image. So it will be a lot slower. One thing you can do is just kill the specular lobe. And if you just go to diffuse, then it basically doesn't have to worry about reflections. And it's also a little bit closer to like an actual volume, because you're not getting transparencies that are getting like illuminated as things reflect. It's just less less busy to look at. It's just more of like an overall cohesive like volumetric form that you would be getting at that point. So maybe we want to get rid of this ramp for a second and just see what's going on. We could also maybe disable these lights, and you can see just with the headlight you're getting just a more evenly lit response. I'm gonna put in an area light, and if you're ever just trying to get the best speed kind of performance, it should be a lot quicker to just light kind of with studio lights like this, or instead of using HDRIs. That should be quicker for most renderers to sample like a geometric light that's a rectangle or a sphere or circle or something like that, instead of sampling an image-based light or an HDRI that's just more expensive for the renderer to be looking up and sampling, and causes more noise and stuff like that. So maybe we'll punch in a little bit closer there. I'm gonna pause the render for a second, and then I'm gonna go into the SOP creation context, and let's try making these particles even smaller. Maybe we want to see even more of them. I feel like the Houdini 19.5, like I'm working at a higher UI scale, higher DPI. I feel like it's messed with my settings a little bit. Like the cursor, it's not always clicking right on the tip of where the cursor is actually pointing. So sorry if I'm clicking multiple times and just dragging and like nothing's happening. So this should be finishing up now. And basically, this is my kind of hacky solution. Instead of doing a full particle simulation, in under a minute we can get like 12 million particles, somewhere around there, that are laid out in an interesting way with some detail, but in very little time, and just for testing or benchmarking or things like that. If you're not worried about an actual simulation, you can just work more quickly and do that. You can also load, if you have simulation saved to disk, you could load it in and try that out as well. But just for testing out render settings and shader performance and that kind of stuff, sometimes it's nice to not focus too much on the simulation aspect of everything, and just know that you have like a fairly standard kind of data set to test with and everything like that. It's possible it's a little faster with the compile block. I'm not 100% sure, because we're creating and adding geometry in like every iteration. I'm not sure how well the compile blocks play with that. It's probably a pretty small difference that it would be making, but we can toss it in. It's a pretty quick thing to throw in. Usually I'm in the habit of working, I guess I don't even know if we need one there. But if you use spare inputs and all of that stuff throughout, that basically makes your simulations like you just have to put the nodes in and you can compile it. And the compiling in this sense should be removing kind of the time or data footprint to copy all these particles between nodes. So in this sense, compiling would be like concatenating or flattening all these operations into what Houdini is seeing as like a single kind of operation or a single node almost internally. And instead of like the scatter doing that and then passing it to the color and then that passing it to that, it's more fluid of a computation and stuff like that for Houdini to manage or figure out. But I don't know, sometimes I've been speed testing this or like trying to benchmark it, and overall it doesn't seem to make a huge difference, but it's always nice to just try stuff out and see what's going on. But yeah, I think in general, if you're ever doing like for each primitive or for each packed primitive or fractured piece or something like that, you'll get the most speed benefits from these compiling that, because Houdini is able to multi-thread all the different iterations, because this is a feedback dependent on the previous iteration's information. It's still going to be single-threaded for Houdini in terms of like running these iterations. The VOPs and like all of these things should be pretty multi-threaded, but it's at the end of the day, I mean, it's just a lot of points that we're working with, and it's a lot of information and stuff for Houdini to manage. Most 3D software, if you're working with like over 10 million points and doing a bunch of recursive like operations to it, it can get slow. I'm just going to delete these. Sometimes with the compiled blocks, if you try to query node information, like it will keep trying to update or retrieve the data, because it's always trying to unload or like keep things out of memory, if that makes sense. Like, so sometimes it can be a little more finicky to work with. But yeah, I would view this as 85 iterations. So that's like, if you have 12 million particles or some pop simulation, and you try to run that for 85 frames, it might take around the same amount of time. But we could always try an actual simulation later on. Seagull Rush. Oi, oi. Good to see you. So yeah, that's an interesting idea. We could try to push this transparency even more and see what happens. To me, this is the closest you could get to having like an actual volumetric render of particles using the Karma XPU shader stuff, because it's somewhat fast to compute, even with all the kind of transparency stuff, as long as you turn the specular off or some other fancy features, and as well don't use HDRIs. That would be the fastest way to do this kind of stuff. I've been doing well. Cooking something cool? Somewhat, yeah. I mean, it's interesting to get into the karma stuff. We're looking at just different ways to render particles. This is from last Friday, and then that was with Redshift, so I'm just looking into some techniques and stuff like that right now with Solaris and Karma. This is with the XPU beta, super bleeding edge stuff. But yeah, I mean, that's pretty cool. The last thing we might want to try is maybe just smacking the detail up even more and seeing what we can get away with. If you really want maybe sharper, just try turning off this cloud conversion for a second and see what happens. But if you really want sharp contrast, you can disable that cloud, and then you'll just be putting them on the surface. But yeah, I think the karma stuff's pretty exciting. I'm interested to see what kind of other features that they're able to get into the XPU feature set. But overall, it's always nice to have a free option bundled with Houdini. For so many years, they've been needing a GPU render, and hopefully they're getting something close to one. All right, so this should be kicking in now. Yeah, and basically instead of filling the shape with particles in this situation, we're able to preserve a little bit more detail because we're just more efficiently like placing the particles where they would be stacking up more quickly. If you put them inside of the shape, it's going to take a lot more of them to form these overlaps in concentrated areas, but if you just put them on the surface, you can have them stack up and overlap more quickly without needing as many of them. All right, so I'm just gonna mess around in the shader. Another thing, I mean, you can do is if you put some saturation into the opacity, you'll start to get the attenuation, or it's kind of like absorption. Like this will basically pull more red color out of the light as it penetrates through the surfaces. So depending on what color you want to visually see, you can put it at like the opposite end of the rotation, the hue rotation. Get some interesting things happening like that. You might also want to try maybe instead of diffuse color, you could even just try emission, and then this would be more of just like a pure constant shader or something like that. That sometimes people are doing things like this with Mantra, with Houdini. If you're really trying to get wispy smoke, or like something like you just extinguished a candle or something like that, you can get maybe some very high definition like curves, like I don't know, for energy or magical effects, that kind of stuff can be interesting. But I think in general this diffuse, putting the extra lighting information and stuff like that in there can be more interesting, for sure. All right, so I'm just going to get a little bit more greedy here, and let's try doing maybe like 4 times the amount of particles. So it'll take a little bit longer to produce the result, but we should be able to have just a more broad shape, probably see some more shadowing and stuff like that in here, and just overall it should help resolve this form to be a little bit more defined and less particulate or whatever. Color rendering. Yes, so with this, to get this color, basically as these are created, it's recording their relative position in the bounding box, and then I'm just using that through a ramp. So basically this is like a left to right gradient, or 0 to 1, and then I'm remapping that color value into just one of the presets, but you could do any color ramp you want. Maybe doing some stripes in there could be interesting, like ramping some other, you can almost get some patterns or stuff like that. You can as well do some sign functions. Anytime you're doing procedural patterning or coloring, like if you have an age attribute, you can just put a sign function through that and you'll get stripes or bands through everything. But yeah, these are these math kind of tricks or ideas I was kind of touching on, or someone was asking about at the start of the stream. But basically, if you're even lighting or rendering or shading stuff, just simple, even compositing, like basic mathematical operations like add, multiply, divide, all that kind of stuff. It's not super wild math things, but just having a sense of what's going on is definitely pretty helpful. All right, so we're 2/3 of the way through. It looks like we're going to be up at 3 minutes now for the total kind of pre-calc or generation time of everything. And I think after this, we can try pulling in one of the simulated caches that I was doing similar to last week, doing a flip simulation. And we'll take a look at how some of this karma business handles that. If anyone has any other karma particle or Solaris general information, feel free, or questions, feel free to put that in as well. So yeah, we're just able here to get, just fill in these shapes a little bit more. I'm going to go into the stage and just eliminate the ground plane. That can give you some more contrast, and it should speed up the render time as well, because we're kind of getting rid of the bounce light a little bit. So I think just in this case, it's going to look a little bit better to do that. That's, I don't know, I'd say it's somewhat nicely responding in terms of performance, like how quickly it's kind of resolving noise after you're panning the camera around and all that stuff. If you wanted to add some fill light back in, maybe we want just the Houdini, this more diffuse HDRI, and we can put that in. We'll have some light kind of bleeding in or feathering in. Maybe we want to fill the frame out a little bit more. I don't know about this angle. The black stuff on the other side of the frame wasn't feeling that great. But yeah, something like this could be interesting. Gonna unlock the camera just so we have this view saved, and it's gonna actually save the file again. And if you guys want to pick this up and mess around with it, you can grab it there. And yeah, I think definitely with the GPU rendering, switch into the image viewport again. With Mantra, it was always difficult to get these indirect bounces that with particle simulations, like colored particle simulations like this, really help make it feel photorealistic, just the indirect GI. And with Mantra, that kind of stuff would take forever. So here we kind of have a HD style resolution, kind of 1920 by 1080. If you switch into bucketed rendering, in general, I think a bucketed render tends to complete faster than a progressive render, just because the renderer is able to allocate resources like more efficiently, and it's not always scrambling around trying to do different things. So if you're trying to get a sense on like overall time for a single frame, I would switch to the bucket render for like a proper benchmark. It seems like we're getting somewhere close to 20 minutes, maybe a little bit higher. And I don't know, I mean, I would say that that's somewhat on par with Redshift. To my knowledge, there's no indirect GI caching. Like Redshift has the light grid where you're able to cache these indirect bounces. So I would say that that's probably where the other speed hit is coming from, is that they don't have any caching of indirect lighting built in. But overall, it's definitely a pretty cool option, cool developments. Z8 editing, good to see you. I'm doing well. I'm just particling my way through this Friday. I don't know where these. I feel like they need a better job showing you where the actual buckets are going. I can't see them right now. But yeah, this is a pretty cool frame. If we want, we could try Redshift, see if we can crash Houdini now that I saved file and everything like that. And we might be able to actually do a real side-by-side kind of speed comparison here. Bing, 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 bing. If you see this gear, that's basically like the pre-render step, and then it would switch to the pencil that would like, it's actually drawing, filling in the image, but the gear means it's like preparing itself I don't know what Mantra would call it, pre-calc. I think a lot of renderers will just call it pre-calculating. We got the pencil. But it hasn't actually started yet. So in general, I would say that this number of particles, I think this was like 50. It generally seems to be pretty slow for GPU renders to pick up. But it looks like Redshift got it. It didn't get the color information. I don't know if Redshift has some issues with that, but it might be because we're in this Karma. But I mean, Redshift should support all these MaterialX nodes. I'm guessing it's this ramp here maybe that I put in, that this is like a Karma specific MaterialX ramp. We could try a generalized let's just plug this right into the color information and see if that works. But yeah, I mean, in general, I'd say that with USD, it's pretty new for these renderers, and not all of them, there's definitely some growing pains or room for improvement on fully being like feature complete or super cross-platform. So to me, that's the biggest frustration right now, is that to use this universal standard, we're still having to do a bunch of like individual support for things. So I think we're having one issue here because this is a rat. This is like a proprietary Houdini image format for that HDRI. But yeah, overall, I mean, Redshift seems a little faster, but it's just less robust in its support for USD at the current moment. I would say it's a little bit more hacked in or hacked on. So yeah, we'll put this one on pause. There are some rats. There's a rat's nest in our mesh. Go back to Karma, and then I'm just going to pause it, and we can connect this back to how we were doing it for Karma support. Ooh. This is actually popped in with the original colors. And then I'm just going to switch this to a file node, and I have some frames here of the simulation stuff that I was doing last Friday. It's pretty heavy simulation data, so I'm not going to spend time baking it out again or anything like that. We'll just pull it in from disk. You could go into the last stream if you want the files there and some other stuff, but basically I just start with a flip tank and just use the standard pop forces to spin all these particles around. And then when I was saving it out, I put some stuff like p-scale as a detail attribute, but you can promote it back to point I just did that as kind of an optimization for the data size when it stores it on disk. So we can do that. Another thing that can be useful if you're just testing stuff, sometimes you want to crop this stuff to just a general area. So if you do that with the clip node, this is just a super easy way to crop spatially. So we could do maybe a crop in like the X direction. You could do a crop in X and Z, and you could just pull a corner. I think having the scene tree open can be pretty slow as well, because it will just to have that cook, it will constantly be trying to pull stuff into Solaris. So this is pretty heavy particle information here. I think it was like 150 million points. And doing these clips should get us here down to half of it. I think if you want to do it even quicker than the clip node, if you just switch to blast, like if I do at p.x is greater than 0, you just have to be careful and set that to points. And this should be a quicker operation. The clip is like 21 seconds. I think if we switch that to the blast, we'll see that the blast is more optimized. That's why sometimes in my scenes you'll see a bunch of blast nodes when you could use other things, but as long as I've been using Houdini, the blast has reliably been like the fastest way to eliminate or delete geometry. That's why I usually stay with it. So we should be able to get back into the stage. These things all have p-scale. They don't have any color information, but we should at least be able to view them and see what's going on. We might have to move the light around. PhD Oliveira, thanks for joining. So let's grab the light. You can always do this correction toolbar. Turn on the alpha channel. That's a handy way of working in the dark. So I can just make sure my light is actually going to hit something. It looks like it's too dim or too far away right now. So we can smack the exposure up. And then let's grab our camera. See what's going on with this rim light. So yeah, these particles might still be a little too big. I think when I was rendering them in Redshift, I was actually multiplying the p-scale down to be even smaller. So I'm just going to go ahead and set that up in here. I think the settings I was using last week was like a 10% of the original p-scale, and then I might include the z axis as well, so you just have a little bit more particles stuff to play around with. So we should see these get a lot smaller, and the distance or the depth of them extend on a little bit more. This should be XPU. I don't know if this is stuff locally I'm doing, but I have XPU. I've been sticking with XPU since 5 or 10 minutes into the stream with Karma. It might just be this branded thing, like Embry CPU is, I think it's a different Intel thing, but it's all under the XPU umbrella, if that makes sense. But yeah, with this transparency stuff I was talking about earlier, this is basically the easiest way you could get to doing something like a volume or something with subsurface scattering. So yeah, the XPU will only support the standard surface, but you can do these little hacks and get some more fancy or advanced results with the render. So I don't have color information. I'm just going to go back to a constant color across the geometry. Let's just put that back to defaults. We'll just make this stuff a little more opaque. I'm just trying to get somewhere in the territory to where we were with redshift there. So it looks like we're going to need more saturation, and we can also reintroduce the specular stuff. Yeah, I'm not 100% clear, but I believe this Embry stuff is like, it's a way of kind of collating these resources and putting them all under one unit that the renderer sees. I'm not 100% sure of the mathematics and stuff behind it, but to my knowledge, it should be leveraging some of the GPU. But yeah, again, I haven't done enough research to really know. I was checking on here, you can see the CPUs are always being used. And there's definitely some utilization of these GPUs that I have going on, like this is at 41%. If I do just halt or pause the render, we check the, maybe it's about the same, but yet I'm not 100% sure. It should be, I would assume, pulling more of the GPU resources. I'm not sure. So the optics is showing up on your kind of drop-down menu, or were you actually using the Karma properties? Because I think you can get some more advanced settings in here than you can just doing the viewport. There might be some driver issues. Maybe I need to update my NVIDIA drivers. I'm just using this 470 build that might be a little bit too old. So yeah, it looks like I need to go up to 495 for it to grab GPU stuff properly. So we'll keep going with where it is right now, but we can come back. I don't think I'm going to be able to update NVIDIA drivers with the OBS stuff going, but we'll be I'll be able to give this a try with those drivers updated in a little bit. So yeah, I can get rid of those render settings. We could turn on some of these environment lights. Yeah, I think sometime in the past I had it working, or I might have been using a different computer that was configured differently. But yeah, I was definitely surprised that it wasn't hitting the GPU as much as it was. And yeah, I would imagine it should speed things up quite a bit. And I think maybe in this case I'm going to make the particles a little bit bigger. It's possible that Redshift, like internally, is using a different, instead of radius, it's diameter, or maybe they're using a slightly different representation of the units, but just in terms of visually getting closer to something like that, I feel like they should just be a little bit thicker. And we'll see where we are with this. And yeah, maybe this is a little bit too much. The HDRI, I'm going to try just spinning it around, and maybe could drop it down. And then yeah, last week I was trying out some different angles. I feel like sometimes just punching in from like top down, you can get some interesting stuff happening. More kind of abstract frames and stuff like that. We had been looking at the Samsung Galaxy, one of those phones, as like a reference point, or kind of like a target to match. But I think this frame is feeling somewhat interesting. I might want to put a little bit more opacity in there, and maybe some more like reddish orangish saturation. You're never really going to get that close in terms of matching one-to-one, but we'll just see if we can get us a little closer in this case. I think in general with my redshift, my specular was definitely a little sharper or crisper. Maybe we want something here with some negative space. But yeah, I'm kind of on board with UZ8 editing. I was expecting like compared to Redshift, I was seeing definitely this doesn't seem as fast. I was a little suspicious of the GPU utilization, but yeah, I just wasn't 100% sure. But it's nice to know that it should be, say, in optics. We'll have to get that sorted out for next time. But yeah, this could be a nice frame here. You have some different structures, different shapes of structures, like more broad stuff over there. I might just play around with these lights as we wrap things up. Let's get into the image viewport. This one's nice as well if you want to do, you can have stuff like full screen, just pressing the Control B, and maybe it is, but theoretically you should be able to switch between window sizes and stuff like that without everything recalculating. But yeah, as you're getting closer to a final result, I would say working in this image viewport is a little bit nicer because you can zoom in, especially if you're having like a supervisor or art director come by. You don't want to be moving things around and having everything recalculate and stuff like that. So yeah, the border, if you're talking about the viewport stuff, if you're looking through a camera, instead of perspective, you can switch to the image viewport using that drop down. And then that just gives you a more traditional rasterized 2D image or canvas or whatever that you can play around with. Seagull Rush, yes, you can post links. Don't slip me anything dirty. I just have one monitor, so what are you cooking up here? There's some Lithuanian, this is like a combination bloomin' onion kebab. My douche. Is this just deep batter? What's going on here? You think this is what it looks like? I'm preparing some of this doner kebab. But yeah, overall, I'm usually more partial to these image-based settings, and then I would say as well not using the progressive renderer and switching to the bucket style render. I'm a bigger fan of that as well. But yeah, for sure, just as you're rendering, it's nice to be able to pan around and not lose your progress on the render. And you can kind of give stuff like a more thorough inspection or whatever. Yeah, it kind of does kind of look like we have some yolk, or it was the it's yeah, it's almost like an eggnog. We have some custard, or yeah, Portuguese. They have the these things. I mean, it's all similar colors, egg based. These aren't as spiky, but I know what you mean. Like the subsurface kind of orange tint and stuff like that definitely lends. It looks like you have some, even like a creme brulee or something like that. Just roasted butter. But yeah, I'll give my GPU drivers an update. I think a while back there was some conflict with Houdini where the UI was having issues with a certain NVIDIA build, so I hadn't been updating them. But yeah, in the future when I do some Karma XPU testing, I'll have my drivers up to date so you can get a proper results there. Yeah, I'm not sure the color attenuation here isn't as strong, but you can get a sense of maybe some. Still wish we had a better photographic exposure settings and things of that nature. We could dial in some more advanced color corrections. If you press the D button, you do have some, I think, very rudimentary camera depth of field. Somewhere there was a bloom, I believe. Bloom. I think we tried it a little bit earlier. I've never been able to get it to bloom things. So I don't know if that's something that's still in beta as well. But yep, I'm gonna call it a stream, call it a night here for me. Hope people have found this helpful, enjoyable, dipping our toes in the world of karma and the bleeding edge world of beta and that kind of stuff. But yeah, I'll be back Sunday, 5 p.m. Western European time, and Tuesday as well. So yeah, I don't know 100% what these topics will be, but should be enlightening, should be interesting. Thanks everyone for stopping by, sticking around, hanging out, and yeah, I hope you have a good beginning of the weekend.